3, 2, 1. I am meteorologist Tim Keller. We're live here on the bluehill.org webinar, Blue Hill Observatory, the oldest continuous climate observatory site. Weather records every single day since way before we were born, which is ever in the 1800s. And Charlie, correct me if I get the time wrong, but it's around 1884 or so. And we just had a big rejuvenization of the observatory with a brand new Mish Michaels Hall for Scientific Discovery. We hope you're all going to come and visit. It's brand new, and we never missed a day of data. Thank Matt Douglas and all the people there. Anyhow, my name is Tim Kelly. I've been a meteorologist since 1987, Lyndon State College grad, Cape Cod native. Got hooked on weather when I went to the National Seashore and Cape Cod in about 1975 for 5 days. And I was obsessed with weather. And fortunately, after my graduation, I was able to get on TV. First in WMUR. Please mute if you're on here. Please mute your audio. And I started at MUR in 87, went to LNE Providence, 88, 89, ended up at New England Cable News, 92 to 2001. Now I'm volunteering and hosting and a weather consultant. And our guest, Joe Bastardi. Please introduce yourself, Joe. Tell us a little bit about what got you into weather and got you to where we are tonight.
Well, I've been into weather since my first memory. As a matter of fact, when I was a little kid, I remember Easter Sunday going to Lord Fox in Attleboro, Massachusetts. I don't know if it's still there. And my dad saying, "See, there's snow flurries." And the next morning, Dad had to work United Wire before he went to get his degree in meteorology. He worked at United Wire in Cranston, Rhode Island, and he would work the midnight to 8 shift. So I'd get up in the morning and I'd sit in my window, and my mom would put me in my high chair. I'd look outside, and there'd be my dad coming up the street every morning. And this particular morning, there was about an inch of snow on the ground. And that was the day after Easter. So we went out to dinner Easter. He had to work midnight. So I went back as soon as I started having access to maps. I said, okay, well, when was that Easter that it actually snowed in Rhode Island? And I went back and I thought, wow, it's got to be 57, 58. But it was actually Easter of 56. Providence had 1.2 inches of snow. And I was less than a year old at that time. And so I reconstructed the whole thing. I couldn't believe it. I thought, maybe I was 3, 4, 5. And, even when I was a little kid, my mom and dad had to keep an eye on me because I'd always loved to go outside, lie on my back and stare at the sun and the cumulus clouds and stuff like that. Basically, I was going to, lose my eyesight. But long story short, I was one of these guys. I've been so unbelievably blessed. The education I've had. Because of my dad, for one, and for two, that taught me to respect guys that came before me. So sometimes I say, Joe, you've never had an original idea. All you've ever done is build off those who came before you to some degree. And I always wonder if I could measure up to the people of my dad's generation that didn't have stuff. And I was blessed to work with Norm Macdonald at AccuWeather for a while. And I'll tell you, man, that guy, AccuWeather was like the New York Yankees. I know you're Red Sox fans, but we're talking about the Yankees when they had DiMaggio and all those guys. I first went to AccuWeather. I was like, oh my gosh. It's like these are the best of the best of the best. And they were unbelievably passionate. They were as passionate as I was. I couldn't even believe it. I thought I was the biggest whack job in the place. But that was a great thing. And then, things just evolved through the years. I will tell you this, at 68, I'm more into it than I was, I don't know. I mean, it's not calming down at all.
So what was it? That's amazing you can remember when you were 1 year old, but what was it about that scene out the window that drew you to the sky, you think?
Well, no, I mean, I was just into the weather. I was into the snow flurries the afternoon before. And the more I started to recall, I was in the back seat of the car. I remember that. This is in 50, 55, 56. So, don't be so, well, your parents weren't obeying the rules. There's a pile of 10 kids in the car at that time back then. But I was fascinated by the snow flurries. And what I remember my Aunt Eleanor, I remember my Uncle Fred, I remember my mom, my dad. I don't remember my brother Matty being in the car. And I certainly remember Matty very vividly after he was born, because he just did nothing but cry at one of my aunt's weddings, and I remember that real well. But Matty wasn't in the car, so I put all these things together. So I can't believe this. I was talking to my dad about it. He goes, "Yeah, it was around that time," because we didn't have a lot of money to spend. So, uh, 55, 50. But I just love the one. My dad's a meteorologist. His grandfather, my dad's grandfather, used to always come and say it was real cold in Providence. Matthew, it's going to snow tomorrow, because the wind would be northeast and cirrus would be coming in. So he'd tell my dad it's going to snow. When my dad was at A&M, it only snowed 4 times down there, but every single time and this is why it's hard to forecast snow in College Station, Texas. Let me tell you something, because if you get too much Gulf inflow, it's going to warm up, and stuff coming from the west is going to fall apart. But every single time, he made me a hero in school. Can you imagine being in 4th grade and telling people a couple of days before that it's going to snow, and then it actually does it? I mean, so but I wasn't in for the glory. I was just in for the snow. So it's funny about snow down south. It disappears real quick. And I grew up, I didn't leave New England till after the great snowstorms of 60, 61. You go down to Texas, it was like, that's why I love snow so much. I was denied it, completely denied it. But I saw it last time it snowed at A&M was a couple years ago, and it was hysterical. The lightning and thunder and everything else. So the A&M golf course had this picture in the morning as a 1 o'clock tee time and 6 inches of snow on the ground. No problem. And then it showed at 1 o'clock completely gone. And that used to torture me when I was a kid. I used to try to pile snow into a place that would be shady and keep it for a couple of days. But so who else has a father that goes to Texas A&M in 1961 with his whole family for a degree in meteorology? And then I was blessed to be around that. My favorite times have been riding out storms with my dad, and now as I'm older, I ride them out with my son. We go
That's
hurricane
beautiful. Yeah, similar. Yeah, my dad was a fisherman on Cape Cod, so I tell everyone, my dad taught me how to read the barometer, and my mother taught me how to smile, and I taught myself how to lie with confidence on television. Anyhow, we're not liars. We just try and do our best, and it often comes out like not as we expect. All right, so on the topic of snow, let's go forth into our winter weather outlook. And I would consider you as sort of a detective, where you're looking for clues across the globe for what's going to happen. And I believe you use mostly analog deciphering. So if you could tell us a little bit what analog deciphering is and what your method is.
Well, analoging is interesting now, in that because the planet has warmed the way it has, especially the oceans. And I keep telling Joe DeLay, I said, well, I don't know if you can use certain analogs from certain times, because completely different feedbacks. You may have like I tell people, oh, the PDO is negative. That's not a cooling, something that's cooling the earth. It's a response to how warm it is. You see?
All right. And that's another thing we're going to have to talk about: PDO, Pacific Decadal Oscillation. So whenever we use the acronyms, maybe at once the first time you say each acronym, you could also say, oh, that means Pacific Decadal Oscillation. Yeah. I mean, if we try and answer every one of these questions, it's going to take us a while. Anyhow, okay. So you look back and you try and use the clues from the past to look forward, and go ahead.
Now, where I really can hone in is at long-standing Pacific ideas. And like, for instance, you watch it, there's a total disconnect between the Southern Oscillation Index and the strength of the El Nino. Of course, this El Nino was very interesting, and we had people following us.
Yeah. All right, Joe, we've got your first slide up. Can you see it?
Yeah, I can see it. I hope people will mute their mics, and because I could hear people talking. But right. In any case, the overall winter pattern this year is setting up almost opposite of last year. Now, last year, what we did, well, we're going to review last year because last year set up this year. The weather flows along, and I do think because of the warming that is going on, it's making it easier to see things if you go look for them. Most people, oh, we got an El Nino. Well, this isn't. This is like no El Nino we've ever seen because everything else around it doesn't look like an El Nino. So the responses are going to be different than what we have something called the Pacific
Okay,
Tropical.
you're gonna get there, right? I know I saw slides on that. So can we go slide by slide and get
Yeah,
into that?
yeah, I'm sorry. This happens to me all the time when I speak. Go on.
My job here is to keep us in check and get us keeping moving.
Well, here's the forecast
So
overall, and it's interesting the way I used all these blended analogs. The first four analogs that were determined at the end of February, beginning of March, coming off the La Nina, were 57, 58, 65,
wait a
66.
minute, Joe. Please explain the slide we're looking at and then get to that.
Well, this is a temperature forecast for this year. This is a temperature forecast for this
It's
year.
going to be 3 below 0 in northern Alabama this
No,
winter.
3 below normal, Tim, not below 0. You go and scare people watching from Alabama if it gets down to
It's
3
going to be
below.
colder in Alabama than northern Minnesota.
No, relative to averages, Tim.
All right.
Okay. Relative to averages. Now, look, folks, what we do is we don't issue probabilities. We issue the actual temperature. Let's say you know your average temperature in Richmond. You say, well, Bastardi's predicted to be about 3.2 below normal. After the November through March period, this is what we do for heating degree day clients. The rubber's got to meet the road. It can't be probabilities. It can't be cold and snowy or stormy and wet and all this. What the heck does that mean, right? So you basically you see all the forecasts, the probabilities. That's not a forecast. The Weather Service actually doesn't say it's a forecast, but the media runs with theirs. Say, "Oh, look, it's a warm winter. It's a probability of an occurrence." This is an actual metrics. When you score a forecast, you have to score it against temperature. You have to score against precipitation. Have to score it against snowfall. All right. So this is a temperature pattern, and it's interesting. So what happened was I came up with 57, 58. These are the analogs. 65, 66,
Oh
02.
wait, should we advance the slide? When you want the slide to advance, let us
No,
know.
not yet, not yet. I'll
Okay.
02,
And this was published in August, which I think is interesting.
well, it first went out back in April.
Wow.
See, people see no
Wow.
one. The biggest thing is the weather is not a snapshot. So some of you young meteorologists, it's a movie. If you get up to go to the bathroom at the wrong time of the movie, you might miss the whole thing. But a lot of guys and weather hobbyists, okay, winter's over. I'm done. I'm not going to look at anything till next winter. That's to me. I'm like, no, that's not. The forecast begins when the forecast is made. So if I say to someone, okay, we've had this forecast out for 9 months. You've sat on the sideline for 6 months. I say you just forfeited the first 6 months of the forecast period, right? So I mean, I'm into competition and stuff like that. But what happened was I set this up back at the end because I looked at what was going on. I expected a strong, what I call migrating Modoki El Nino, where it starts very warm in the Eastern Pacific and moves into the Central Pacific by the winter. What examples were those? Well, 57, 58 was one, 65, 66 was one.
We're going to get to that, right?
Yeah, we're going to get to 02, 03, 09, 10. So what I'm saying, I'm explaining the evolution of forecasts. This started in late March, all right? So when August came out, we put this map out. Now, what did this map represent? Well, it represented the fact that, there are a lot of people with a lot of good points, and I see the way it can be very warm. I see the way, I mean, we got people thinking it's 1997, 98. Who am I to say, well, that's wrong. I don't know if it's wrong. You may believe something, but you don't know something until it's done. So this is what we came up with. Now, other analogs got added. 86, 87 got added. Recently, this stratospheric warming event that's supposed to occur. And what happens is the stratosphere suddenly warms. And when it suddenly warms,
Jeopardy? One at 7.
All right, please mute yourselves. All right, Joe, can we go on? Can we move forward in the slides?
yeah, move forward so you can see the snow. Move a slide forward. So here's the snow. And what does this mean? I mean, well, the Great Lakes is going to be below normal. That's not a probability 133. You know what that is? In Mount Holly, New Jersey averages 24 inches of snow a year. It says they're probably going to get close to 30. That's what that means. It said Boston and Providence looks like 115, 120%. New York City about 133. So what you do is if you know your normal snowfall, if you know your average, you look at that as a percentage of it, and you come up with the how much snow you're going to have, so you can judge my forecast. Richmond averages what, 9 inches of snow a year, and so I'm predicting 13 inches of snow in Richmond and 3 below normal. Snow is first flake to last flake, and the temperature is a 5-month period, November through March. Now, why do we do that? Because I'm involved in the energy business, and we're looking at heating degree days. And for instance, the Northeast will probably wind up with above normal heating degree days in the month of November because it's cold to start. There's more chill coming, warms up for a while, whatever, right? But much of the country will be behind until we see how this breaks. I think it's going to break the third week of December. And then I think, for instance, I think January could go crazy, but we can talk about that later. Okay, so here's, all the analogs, and I weight them. I say, okay, do I want to give this a certain amount of weight or that amount of weight?
This is temperature.
Yeah, this is temperature.
And yellow is warmer and green is cooler.
Yeah. Okay, so you can see the analogs match the forecast because the forecast is drawn off the analogs. And you got to understand, everybody's looking at all the models and the different models and this and that. Models now can't detect cold. If you've been watching it, it's so warm that it washes out all the cold. So the places to look for it being cold in the winter are downstream from the ridge. Models do much better with ridges than the strength of troughs, and that would make sense given if you're looking at something that's biased a little bit warm. Because what happens is, let's say it's warm in certain places, you wash it all out, and when you wash it all out, it winds up slightly above normal all over the place, and then the feedback starts, and look out, right? It just tails off. So we have to incorporate the analogs into the models. But if you took this as a blend, let's say we blended this morning's CFSV2 run, because the 10-day runs have no winner in the United States.
Anybody knows what that means?
Well, I assume this is my fault. I assume that if people are on this, that they're weather fanatics. So
can you just tell us what CVS is like? I mean, a lot of people know the Euro and the American and all that, but not
it's the U.S. model. It's the U.S.
But
model.
it's not a 10-day, not a 20-day.
No, it goes out for 9 months.
9 months. So there are guidance models that go out for 9 months. Is what Joe was saying. Thank you.
9 months. So,
okay. Sorry, slow you down.
The blend of all these models, and including the JMA, people that follow me know I love the Japanese model. I think it's outstanding, and it comes out with something like that. So it seems like the analogs are agreeing with the model blend.
All right, okay. And just for people that maybe not have the best eyesight, so the years Joe thinks that this might be similar to at top. I assume at top is on the left, 97, 98. That's one of the tops.
Yeah, wait, see now look, there's 2 of the warm stinker winners in there. You see that? It's not that
15, 16 is what you're talking, warm stinker winter, right?
Oh, well, there was one blizzard that made the winter, right?
Yeah.
It was a one-shot wonder. But because I see people tell me what people are saying. And it's not like I don't see the warm option. So the warm option got factored in there. If they all clustered to the cold options, then
0203 was kind of memorable, I think.
Yeah, it became memorable because of February. I mean, it was 76, 77 was a brutally cold winter.
Cold, but not too snowy, right? Yeah.
Well, it depends on where you were, too.
Right.
So anyway,
all right.
69, 70 was a wild winter. They did 86, 87 was Washington's winter until 09, 010 came along. 09, 10. 86, 87 was just a mid-Atlantic winter. It was very, very mild to start. And then mid-January, everything changed. It was one storm after another. This is going to be a very stormy winter. And if you take a look at the forecasted pressure patterns across Canada, the forecasted pressure patterns were all high pressure to build across Canada during the winter. And
What is
even,
wind? Air that moves from high to low. So if you have high pressure in Canada, the air comes from Canada.
right. So what happens is the air mass may be above normal in Canada. Let's say it's 5 above normal or something in Winnipeg. But if it gets delivered into Boston without a lot of modification, Boston winds up below normal. So you see, it's an upside down pattern this year. We can move to the next one. Now, here is what I'm talking about. This is unprecedented. There's not supposed to be warm water to the north of the El Nino.
We're looking at the anomaly of the Pacific Ocean. Red is really warm. Blue is relatively cold. Sorry, go ahead.
Now look at look at the normal case. If we go to the next one, the average. Go to the next slide. See what? So the feedbacks have to be different. There's very little difference in the sea surface temperature in the North Pacific, the anomalies with the anomalies in the El Nino area. That is got to be a
all right. Now, Cheryl, can we go back one again? So everybody look at the 1 and the 3, and you see how cool it is in the North and South Pacific. Whoops, no, that too far. Yeah, that one. So there is some in the South Pacific, nothing in the North Pacific. So what are the implications with that, Cheryl? Thank you.
Well, the feedbacks are going to be different, and you can't just say, oh, it's a strong El Nino like 97, 98. It's a completely different look, because if you don't have much temperature, look, everybody looks at the temperature, but it's a temperature difference that really drives things, all right? If there's not a lot of temperature difference, what you do is you go back and look at El Nino years where there's not a lot of temperature difference. And that favors the weaker El Ninos. And folks,
interesting. Right. So if it's a strong El Nino is just relative to the temperatures around it, huh?
Yeah. Well, if it's well, I was just going to get to that, Tim. If you go see, look, there's a lot of things to look at. I get frustrated because I believe a lot of us are meteorologists, and the meteorology community, I'm amazed at the lack of curiosity today. It's like everything's too easy. But look at the Southern Oscillation Index. We just had an October where the Southern Oscillation Index didn't even fall into the El Nino category. That is a big rarity. And some of the winters, 76, 77 was like that. That there was, 69, 70. Some of the winters where that happened were huge winters. So we're not seeing the atmospheric response. Go to the it's not on here, but the multivariate ENSO index is my favorite. Why? Because it takes into account what the atmosphere is actually doing. What do we care if the ocean's warm and the atmosphere is responding in a completely different manner as it is this year? So we've never seen these discrepancies. For instance, the multivariate ENSO index ending in September was just plus 0.6, barely into the El Nino. Meanwhile, 1997 and 2015, it was already at 2.2. How are they?
Is that due to the warmer waters surrounding the Central Pacific?
Yeah, it changes. It's due to the parameters they use. They use atmospheric parameters to go along with the sea surface temperatures. So the atmospheric parameters are not responding the way they did in the years where we had the super Ninos. So that throws a different light on it. And the other thing is the Pacific. We've got a cold. It's rare. You've got literally a cold PDO, with an El Nino. Because
please mute yourselves. We're in a cold PDO with those sea surface temperatures.
My bad. We're in a warm PDO with an El Nino.
That means Pacific decadal oscillation. The Pacific changes from warm to cold every decade or so, roughly. And so we're in a warm PDO and we get an El Nino.
Yeah. So the warm PDO is when it's cold in the Central Pacific and it's warmer. You see the ring of warmth over there off the west coast of the United States. So
on this slide.
So very, very different from what we have. We just had I haven't seen the newest one in October, but we had 3 record cold PDOs in a row, and that is unprecedented with an El Nino. So these things are part of the balancing act of the atmosphere that it's forced to get into because of the different feedbacks due to the oceanic warming that we're seeing. So,
All right.
anyway.
Well, this graphic is really stale now. Let's go.
Okay,
What do we got there?
this. Okay, now try to stay with me here, folks. This was the vertical velocity forecast from the Japanese model for last winter. Notice,
all right, for vertical velocity means is the air going up or down. If air goes up, it tends to be stormy. If air goes down, it tends to be high pressure and not so stormy. So is orange the air going up?
down.
Okay. So
Blue,
orange is air going down. Blue is air going up. Gotcha.
Right. So there's a tremendous amount of convection in the Eastern Indian Ocean on into the area just east of the Philippines. Now, this feedback releases heat into the atmosphere. And this is a classic phase 4 and 5 of the Madden-Julian oscillation. Here's the thing. If you go on the Weather Bell site, all right, and read the winter forecast, you're going to read so many things that you're not going to see anywhere else. All right. So I'm just trying to explain this here. But what I want you to do is focus on the Western Indian Ocean. You see how it's got the light brown, and you've got the
far left.
Right. You've got the blue over Southeast Asia. Now go to the next slide. That is right in line with it's forecasting the warm phases of the MJO to dominate, Madden-Julian oscillation. Why is this important? Because pressure and precipitation, outgoing long wave radiation in the tropics is extremely important into the feedbacks of the atmosphere that drive the global.
Could you just spend 20 seconds on Madden-Julian oscillation?
It's a rotating band of low pressure through the tropics that tends to circle the globe every 40 to 60 days, but it repeats itself strongest in areas that are most favorable.
So this sends a wave across the entire planet all the way around at that low latitude.
Yeah, but the wave disappears and then regenerates. But if it keeps regenerating in phase 4 and 5, it keeps pumping the warm signal in. Go again. Oh, Southeast Asia. Notice the Southeast Asia blue, and you see the phase 5 is warm in the Western Indian Ocean. Now go to the next slide. Bingo, you've got your correlation to last winter. Look at phase 4 and 5. The entire country is warm. Except,
can you zoom in a little bit more?
Yeah.
Phase 4 and 5 are down. Okay. 4 is down there on the left. That is warm. Okay. Now 5 up on the top is warm. So what's your point?
My point is, if you can figure out what the Madden-Julian oscillation is going to do, you're going to nail the winter forecast. So what happened was last year, what we thought was we knew there was going to be a lot of pressure out of the Eastern Hemisphere for warmth, but we also saw some colder signals. So we never had the East Coast warm or cold. We had all the cold in the center of the country. What happened was the complete dominance of the Eastern Hemisphere signal took over, and that's the end of the game. It's just warm. And once it started breaking in March, when the MJO got around to 8 in March, the cold started coming. And we've been seeing the MJO rotating into the colder phases since then. So if we go to the next map, this is the Japanese this year. Excuse me, you see what phase 8 looks like? See what phase 8 looks like? It's opposite, right? Where's the orange? It's over Southeast Asia. Where's the blue? It's coming off Africa. Now go to the next one. This is the forecast. This year has the opposite look of last year.
Oh, I'm sorry. So what we were looking at a couple minutes ago, that was last year's MJO?
Yeah, last year, and this is this year. So those signals are the opposite. Now, does it produce the opposite effect? Well, yes and no. You know why? Because, and this is why, if you're a real weather fanatic, you get on Weather Bell, because we'll show you the different things that go on. For instance, the response of a phase 8 El Nino is different than with your phase 8 in a La Nina or La Nada, as they call it, right? So there's not only do you have to deal with the change in the pattern, but you have to deal in the change in responses. So that gets factored into the forecast. So the dominant phases, at least the dominant signal, and because we're a global weather service, we watch everything. I mean, we're on top of the. I talk to people in India. You know, when I meet them, I say, "Oh, I'm constantly on the Indian meteorological site over there because I'm looking at this stuff." So it's key to look at East African rainfall, and if it's rainy in East Africa and dry in the Eastern Indian Ocean, it's usually a cold signal. The opposite is true. If it's wet in the Eastern Indian Ocean, it's a warm signal. A lot of times, if it's cold outside and you see thunderstorms going off in the Eastern Indian Ocean, you say, oh, 10 to 15 days, here it comes. It's going to warm up. So we watch that stuff all the time. So the dominant phase this winter looks opposite last winter.
Got it.
Now here's the JMA for winter, and this is a tremendous. This would be a tremendous winter. You know why? Because you've got the ridge. You've got what we call negative EPO. You got negative NAO. Well, by that I mean the teleconnections are when you have a ridge in Alaska, trough down to the south. That obviously.
All right, Joe, I'm going to have to explain a little bit right here. This is pretend we're up in space looking down at the North Pole, at the entire northern hemisphere, and the orange indicates ridging, and the trough indicates the blue indicates troughing. So ridge in Western North America, trough in Eastern North America. Thank you. Go ahead.
Yeah, that would be like God gave me pencils to draw the winter. All right, so this is a Japanese model. Okay, so go to the next one. Now the euro is a threatening one too. People,
Yeah.
oh, well, euro. See, let me explain what's going on, folks, and I'll explain this again. If you put a ridge someplace, the response to the trough will be stronger than what the model sees. If you can figure out, well, where's the trough going to be? The model can't see the trough as strong as it's going to be. And why would that be? Because the backdrop of the whole thing is a warmer situation. So what is key to this and key to the JMA is they're both forecasting the kind of blocking I haven't seen since the 70s, where the ridge also gets back into Western Canada. What is important about that? Well, it means that huge highs can generate from Alaska as well as from Hudson Bay. And a lot of times our blocking situations, the only ridging is up over Greenland or Northeast Canada. So this is to me, I looked at this, I said, oh boy. But
may I interject that this started in the middle of October. Our first Arctic high came out. I don't know whether it originated in Russia or Alaska, but we had record cold in the east 2 weeks ago and record cold in the west. And that front, the Arctic front that finally made it into the Atlantic Ocean, spawned that incredible storm in Europe last week also. So what Joe's talking about is already started, in my opinion.
Well, yeah, I don't think, I don't mean to disagree with you, but that we're not yet into this pattern. So yeah, I didn't really study.
Well, it's a heck of a shot across the bow.
Well, yeah, it is. But, we saw what happened in 91, 92. Same thing happened after the perfect storm occurred. It got real cold. After Sandy, there was a foot of snow in Freehold, New Jersey the next week. So, the pattern, November is what we call, October and November are what we call saddle months. They're really hard to get, by that we're saddling over from summer to winter. So you have a certain type of feedback when the jet is increasing. You have a certain type of feedback in the atmosphere when the jet is in a steady state, winter or summer. And then you have a certain kind of feedback when the jet is weakening. So, we've always, in this particular case, it may be the perfect telegraph for all that. But then someone will say, well, how come all the warm weather keeps coming back? Not New England, but in the Central Plains. Right? We've been seeing that repeatedly. These cold air masses come through and it warms up after. So, but look, this is a winter forecast, and that did help spawn those storms. But the other thing that, if we want to start talking about Europe, and I have clients in Europe, when it rains, it's usually a sign that the trough is going to be established for the winter. Why is that? Because it's showing you it's trying to penetrate. And that happened the last time I saw rain and storms like that were the mid and latter part of November 2009, and then winter went wild in Europe. Remember, it went wild in Europe first, even though we had the big snowstorm back in December of 2009. Remember, the next day after Christmas, it was gone because it got so warm, right? So the winter didn't really set in until January, February, March. But in any case, to me, those storms blasting Europe means that they're going to have a rough winter over there. I guess we can move on. Okay, so I want to show this. I want you to look at the Japanese evolution, and this is the blue represents below normal heights, the orange above normal heights at 500 millibars. You notice the way it looks, it's centered over the southern plains because the trough is going to start in December in the west and southwest and then start working its way across. And hopefully it's worked its way across enough so that by the holidays, we have some fun and games to figure out with, because the evolution of this, if you look at this, now go to January, go to the next map, to go from that to that.
Ooh,
and
wow.
This is saying that January is going to be lights out tonight, trouble in the heartland. I mean, that's what that is. That's just Badlands by Bruce Springsteen over there. I mean, I looked at that and I said, it's one of those things that, oh Lord, I don't pray for the weather, but if my friends are praying for it, let them pray for this. that's just wild right there. And so you would start this. I mean, I expect Christmas, the holiday week. I expect Thanksgiving week to get stormy. And then it backs off. And then I expect us, after December 20th, we're going to start evolving this pattern toward what I believe will be a trough over the eastern part of the United States with plenty of blocking over the top. So if we go to the next one, we'll see. There's a stratospheric warming going on for December. Now, there are a lot of people that are hitting me online and saying, no, it's not
stratospheric. Wait. What does that mean and who cares?
Okay, folks, think about this. You have the troposphere and you have the stratosphere. And so if
the stratosphere is up above the troposphere where most of our weather occurs.
If the stratosphere expands, what has to happen to the troposphere underneath it?
It contracts.
And what happens when a column of air contracts?
Well, this is what's confusing to me, and I've been trying to figure this out for a long time. When we have lower thicknesses, it's colder, but compressing something makes it warmer. So to me, it's a little bit confusing.
What it does is it builds the pressure. It builds high pressure. And you build high pressure where there's no sun at all. It gets very cold. Okay. Now, if you run the storm track underneath it, where's the cold air going to go?
I see. Right? So it really bundles the cold near the surface, which is going to have to release at some point.
Right. And what has to happen here, too, is that the vortex usually gets destroyed after that. And that's when the vortex gets, people say, well, like it was saying to me, the vortex isn't destroyed yet. And I said, well, it will get destroyed if that's correct. And you can see that actually, if you actually go look at the winter forecast and the
that's another thing. So what he's saying is that the spin of air that's often just locked up over the Arctic will release. And that's a new thing. Polar vortex.
Okay. Anyway,
not new.
I apologize for the assumption they had all weather nuts on.
Well, we are all weather nuts, but
All right. Well, anyway.
Thank you.
So that's only occurred in December when El Nino years in very few years. It's rare. I mean, it's 2023. When we look back through 1950, I think it's only 4 or 5 times. So if we go to the next one, right? So these are the past years that happened, right? And what you can see, I've got them across the bottom over there. What I did was I weighted them.
There's 2014 right there on the left.
Yeah, it occurred in 2014, but we didn't have the same kind of El Nino. But
78.
here's the point.
I mean,
if you look at that map there, for what December's 10 millibar looks like, and you look what the Europeans going to, go back up to the map before. if you go back to the map before, they look identical. Now, how am I supposed to ignore that as a signal?
And where's this guidance coming from right here that we're looking at right now, Joe?
This is ECMWF.
All right, that's the euro, so to speak. Yep, got it.
Yeah. So anyway, we move to the next slide. So what? So
no, you
what?
skip one. Yeah.
Okay, move to the next one. Here's what the winters look like.
Oh, oops.
And what happened was December. Go back to the one before. That's what December looked like. January was colder.
Temperature anomaly.
Go to the next one. See that? January is colder.
January temperature anomaly. Cold across the entire lower 48.
Now, here's the problem with this. We have to, I didn't adjust this because what happens is some of these years are from where the normals were very much colder. And so if let's say I added a degree, it would make for a better presentation. But I wanted to show you the pure analog because I am concerned that we could actually get it as cold as what we've seen in some of those winters back in the 70s, 80s, most recently the 90s. I mean, everybody talks about 2013, 2014, and 14, 15. Remember, we did not have a cold December in 14. The weather broke, right?
Yeah.
Remember? All right. So,
yeah.
My problem
did a great job.
My problem with this winter is once it gets cold, it may stay cold right through February and into March. And I think it's going to be a late winter to end. If we go to the next one, so there's February. You can see the classic everything cutting underneath over here, right? The coldest is in the south and east. And then we go to March. There's March.
Go ahead, Cheryl. Yeah.
Now, isn't this interesting? Remember the 2009, 2010 El Nino winter? Folks, remember? What happened the first week of March? There was a rainstorm that was beyond belief in New England. Winter, that was it. Winter broke. And so sometimes winter breaks over the Northeast first. I don't think it's going to be that case this year. But it's very interesting that in those analogs, it actually runs its course in January and February and then tries to fall apart in March there. Go to the next one, if you can, Cheryl. So when we look at the heart of the winter, December through February, this is what you come up with. All right. So that's based on, analoging El Ninos with these strat warms that are going on. So that's a cold signal. Go to the next one. Let's see what we have. So this is the next one.
I can't see the top. Cheryl, I can't see the top.
I know what this is here. I'm sorry. This is where there were cases where the Pacific Tripole,
That is a slide we looked at quite some time ago where it showed the warm over the equatorial Pacific and the chill in the North and South Pacific, right?
Right. When the 3 years that we had a similar tripole and we had a stratospheric warming event in December, this is what happened.
Oh, very similar.
Yeah. So you see what's going on here? For those of you watching, I'm taking all these different angles, and they all seem to be converging on what a blend, let's say, of the Japanese model, European model. I didn't put the UK Met on, but the UK Met looks similar to it as far as the 500 millibar pattern goes. They were all converging toward that. And yet you saw me also factor in the warm years. And what's interesting is that I always show my work and show where I'm coming from. And I always wonder is, well, when this guy, this forecast comes out, is he looking at the TPI? Is he looking at this? I don't know. So I can't concern myself with what other people have out. But I do recognize what some people are very skeptical about when they look at our forecast. But on the other hand, I'm sitting here saying, last year I was very worried when we put the forecast out in the East, and I said so. I said, so I'm worried about being warmer than what we have. And the reason I was worried about that, but that's not you can't say that. If I have it one above normal in New York, it winds up above normal, it's a plus. But I'm just saying that I was fearing the warm option. This year, this is about the first year I can remember that I'm fearing a colder option than what we have. All right. That I think, we could really be very, very cold in January. Remember what happened? Remember what happened? What was it? 2004, January 2000, and even February 2015. I went out with 5 below normal in New York, and people were going out of their minds saying I was insane. It wound up 10 below normal in New York. Sometimes the weather will gravitate toward the extreme, right? We got to remember averages are a product of the swings, some minor, some major. Okay, let's go to the next one. Everybody's falling asleep. Oh, here it is. Here's the brutal examples of strat warms and what we call weak multivariate ENSO index winners. 69, 70, 76, 77, 77, 78. So what am I showing you? I'm going to show you what I call clusters. Here are the brutal ones. Okay, here are the brutal ones in the analog. See that? Look at that. That's like, oh, look out. There are ice flows going into New Orleans, snowing in Miami. Let's go to the snowy ones. I think the next one's the snowy ones. Yeah, here's winners, for instance, 86, 87, 02, 03. They weren't as cold, but they were major snow winners. Notice that warmth in the northern there, right? And you can see the cold in the south and east. Now we go to the biggest underachiever of the bunch, 06, 07. This wound up being known because December was so darn warm you couldn't overcome it, even though January and February were colder. But this was the famous jet blue winter. I don't know if any of you remember the time that they were predicting at LaGuardia a massive sleet storm to change over to heavy rain so they could get the planes moving, and it didn't. People were sitting on the runway. They had 5-6 inches of sleet, February of 07. And these are the stinker winters right here. You can't go to the next one. This is like, and this is what some folks think is going to happen. But it's you see that it's in the analog. There's one that sticks out that way. You have a cluster that sticks out colder. So what am I doing? I'm playing all the research down the middle over here to some extent. But that 91, 92 was horrible. But I was looking
your microwave. Can I help you again this year?
What was that?
Here. Can I go use it?
Mute.
Okay. Go to the next one. I'm more fun when I'm up in front of people. So here's I really get into it. I bring a squirt gun up there. If I see someone falling asleep, I squirt them. By the way, we are recording this, so if you have trouble sleeping, you can get the recording of it, and you'll be out like a light. Colder, stormier winter than last winter. It could be a great winter. Obviously there are opposite feelings on that. The current forecast temperatures November through March. This is for New York City, 1 to 2 below normal. New York City, 26 to 35 inches of snow. And so again, November through March. Boston, normal to 1 below normal, 32 to 44 inches of snow. So you could say, okay, well, we'll see how close you are with that. All right.
How about Mount Washington?
I haven't looked at that yet. It's funny. There's an outlying analog, 68, 69. That was the year where they had to close all the ski areas in New England in February 69. Remember that?
That was the snowiest winter on record at Mount Washington. There was like this 100-hour storm.
Yeah. And that was a fascinating storm because we had no snow in Atlantic City from that storm, but March of 69 record-breaking snow down in Atlantic City. That February 69 turned out to be pretty wild because it was a Lindsay storm. You folks know what the Lindsay storm is? Let me tell you what the Lindsay storm. So in 1969 February, everybody's forecasting rain for this storm. So Mayor Lindsay, New York, he decides it's not. I don't have to be in town this weekend. I'm going to the Bahamas. He heads for the Bahamas. Meanwhile, it's in Cosen's book. He says it was really got him into winter storms. He said they were forecasting rain and huge flakes were coming down. Right, so wound up with 20 to 30 inches of snow across New York, and Mayor Lindsay did not plow Queens until the end because Queens did not vote for him. So it's a little bit of Chicago there, but in any case, well, that's the presentation.
All right. Thank you so much, Joe. And we can take questions in the chat room if anybody. There's not too many questions showing up in the chat room.
See, that's because I answered everybody's questions.
I think so. That was really fun. It's just great. And of course, Joe is on Weather Bell, and Tim Kelly is on YouTube.
And we're also on. I'm also on a podcast called The American Storm, which if it's on Spotify and all that stuff. And that gets a bit. Of course, somehow or the other, everything gets thrown in there, including football. So.
And where is that?
The American Storm. It's on Spotify. It's on all the things you can get it. I put a link up on the internet to it, and we just did episode 9, which was what the heck did we talk? Oh, we were discussing climate justice. I'm trying to figure out what that is, but that's another story for another time.
Another story altogether.
I did give a pretty in-depth look at the upcoming winter also. But you can get that look. This, if you go on Weatherbell, I of course want people to be on the premium site, but on the public site, we do something called the Saturday Summary, and a lot of this stuff I've been showing this for quite some time, so it's not like it's new. Anyway, no questions.
All right, we got a couple questions, Joe. What kind of? Wait a minute. Do you foresee freezing temperatures in Georgia this winter?
Yes.
It was like 27 the other day.
No, I've told my relatives, for instance, in Conroe, Texas, I expected them to take pictures of snow this year. And a lot of these El Nino years, it snows deep into the southeast. And I expect Georgia we have above normal snow year in Georgia. Macon's greatest snowstorm was in the 72-73 El Nino, which was a snowless winter in the mid-Atlantic states, but Macon had close to 2 feet of snow.
How that is just a spectacle of nature.
Because I was watching the darn storm go off to the south of me, Atlantic City. I got beaten in a wrestling match the night before. Someone egged my car. And can you imagine what it's like? You can see, it's unbelievable. Saturday night, I lost the wrestling match 5-2. I couldn't get off bottom. My Aunt Eleanor was at the match. She screamed so loud, she lost her voice for 3 weeks, right? So, and this is how this is all, because Norfolk got a foot, and we were getting nothing except gales out of the north, temperatures in the teens. And the next morning I wake up, someone has egged my car. And the frozen egg on my blue Mercury Comet did not. So I remember that storm very well. Bare ground.
All right. Well, Jerry Sullivan reminds us that the new 30-year normal is 48 in Boston. So it's getting snowier as the world gets warmer, which is interesting. Marie was the one that asked about the Georgia.
Let me make a comment about that. My dad gave me a book when I was 8 years old, Why the Weather, I believe. It's Tanhill's book. He gave me 2 books. I don't know which one. But they had a whole chapter on climate change in there. 1963, I got this book. It says, if it gets warmer, it's going to snow more.
Right.
And because it gets warmer, but it doesn't get warm enough, right? So, it hurts people more to the south.
Right. And the Arctic, the poles are supposed to be, desert tundra. And if they're going to start melting, we're going to have more moisture available where the sun doesn't shine. George, what kind of forthcoming weather data would cause you to lose confidence in your forecast?
Well, there's plenty of things that are challenging me already, and I'm watching to see. Okay, you saw me lay out all these analogs and all this. It's like this: who's going to take over? And there's an argument as to who's going to take over. Like I said, it's not that I'm not seeing the other options. They're there. They're in the analogs. But right now, from what I'm seeing, and again, remember, I am looking at things that I don't think. Go down the Weather Bell premium site, Weather Bell. We have our winter site public. Read, because I put all this stuff on. You will see that that's a different discussion from what you're seeing from other places. I'm looking at things. The Apostle Paul said something very interesting. Those who know what they know don't know what they ought to know. And I take that to heart all the time, that whatever I know, the key to the final answer is what I don't know. So I'm constantly looking for things and trying to come up with different angles. If you follow, if you're on Weather Bell Premium, you see post after post after post saying, look at this, this only happened in this year or that year. And so there are things that will make me change. Now, what's interesting about this is probably through mid-December, not much is going to go on in the eastern part of the country, right? And, I remember one of the winters, 86, 87, I was in Providence, and my dad says, well, another brown Christmas, Joe. And I looked at him, I go, we're going to see what you're saying in a month, Dad. And January 87 came along, and he called me up on the phone and said, that's enough. No more, 3 storms in a row right through DC and Atlantic City. So, and let me again bring up 2009. Now that everybody, a great December snowstorm. Hey, that could happen this year too. That could happen this year. But winter disappeared so much in 2009, 2010. I tell this story all the time. The second Thursday in January, my son was playing basketball. And I called up DeLeo because we didn't get the European at AccuWeather. All those years you saw me at AccuWeather, I never saw the European, right? So I was forecasting without the European, which meant that God's divine hand got into some of the correct forecasts. But the point is, everybody was looking at the other thing. So I called DeLeo up because one of our clients had gotten on the air and said there was going to be no snow in DC for 3 weeks, right? And I called DeLeo up, and I didn't have any communication with the guy, but I heard what he said. I called, what, am I missing something here? What's the European look like? He says, it's all blocked up. He says the trough is right along the East Coast. It looks great. And sure enough, Snowmageddon began 9 days later in DC. The first one was January 22nd. But remember, it didn't do squat diddly for a whole month, and people were giving up on that winter, right? So what generally happens in a lot of these winters is a lot of it comes in 3 and 4 weeks. 65, 66 didn't do it. 60, it was 60 degrees in Providence, December 25th, 1965, right? And here I come back from Texas, right? As a little kid, I'm going, oh, we're back in Rhode Island. It's going to be a white Christmas. It's like boiling outside. I couldn't believe it, right? El Nino year. Okay. Look what happened. Look what happened mid-January to early February. Okay. 82, 83. It's 67 degrees in New York City on Christmas Day. Blizzard of 83. So what generally will happen is this will be compressed into a certain period. Now, the question is, can we get it to run from, let's say, late December into and through February? That's a hard thing to pull off. But that extreme is on the table, just like the other extreme of, the stinker winter is on the table. So it probably will fall someplace in between.
We got a bunch of questions here. Amber says, what do you think about global cooling?
No.
All right, good. Done.
Until
done. All right, Jerry.
Well, I answer the question. Until such time that I don't see increased geothermal input, people don't know about it, but I've been watching it since 1990. You're not cooling the earth if the oceans don't cool. I don't understand. Oh, the solar cycles are doing this and this.
If we go there, Joe, we're not done till 9 o'clock.
I've been hearing this solar cycle stuff. Yes, over a period of centuries. Obviously, it's the sun. But if you're looking at these decadal changes, you got to, where's the source of heat, folks? It's in the oceans. Until you can cool the oceans, forget about it.
And he's saying that the oceans are heating because of the center of the earth. Anyhow, Jerry asks, are you actually predicting Boston to have well below normal snow? seems not.
I
No,
thought that was near normal snow, wasn't
no,
it?
yeah, he said near normal. Joe says
thought it
wonderful
was above normal.
presentation. Amber says you did. You said it's close. Amber, something's going on with the UAH temperature. The atmosphere is going to have to respond to El Nino and Tonga.
It already has.
Too deep. Yes. Peter, will the easterly QBO be a factor in the upcoming winter? Is it supposed to be
yeah.
easterly?
Yeah. Yeah.
Quasi-biennial oscillation. So Joe Bastardi's partner, Joe DeLeo, was the first ever long-range winter forecast I had ever seen. I met Joe before Joe. And anyhow, is it supposed to be easterly or westerly?
No, easterly. He told me it's already shifting. So yeah, that adds to the equation. But I'm not as good at Joe as that stuff. And he, we talk about it. Listen, Joe's analogs, they're cold. They're real cold with that QB.
Even with an easterly? I thought he said something about westerly about a month ago.
No, it's well.
So quasi-biennial oscillation is just the wind way up there, right? Like 200 millibars or something like that.
I thought it had switched.
All right, Lydia, why does the snow rain line run along the Mass Pike? The question really is, why does the Mass Pike run along the snow rain line?
or
and then there are tornadoes that follow the pike.
Well, that's an interesting question, because we've had the same kind of phenomena about enhanced thunderstorms following the trio of roads, the Atlantic City Expressway, Black Horse Pike, White Horse Pike, from Philadelphia down. I think the rain snow line is mainly I-95,
right, or 495, right? It's just so helpful as a meteorologist in Boston to have these roads along these lines.
Well, they built them for you.
Yeah. So and plus the I-90 here in southern New England, its proximity to possible cold air damming to the north and the warm air advecting from the south. I mean, it's just a perfect thermal and moisture gradient there too. Amber's asking a lot of questions. There is the solar maximum correlation with stratospheric. There is the solar maximum correlation with stratospheric warmings. Is there?
I don't know.
I don't know. Kevin, why does NOAA always forecast warmer than normal winter temperature for the Northeast?
Because it's been warmer than normal most of the time. It's a good forecast. I mean, it's persistence.
Mr. Yaku, I'm not a weather geek, but it was easy to follow. Thank you both. We need more like you. This is Jerry from North Weymouth. All right, Jerry. Joe, again, are there problems, Kevin? But there's a lot of above normal temperatures on the planet. Are there, again, there are probabilities. Oh, I think those are people chatting amongst themselves. Thank you for the presentation. Good minds at work. 1415, Fred says in 1415 snow started January 27. And yeah, we know that. And Joe DeLeo made an amazing forecast for the observatory that winter, and it worked out perfectly. QBO is
amazing forecast. Joe, there'll never be another Joe DeLeo.
Yeah, and so you got to sign up for Weather Bell Premium and read Joe and Joe's blogs. Jerry, 0708 La Nina was great pike demarcating winter. Boston had 51. People 30 miles south had half. People 30 miles north had double. 0708. Thank you, Jerry. Good intel. And Joe, just for the record, on one of my blogs, when we did our interview on Cape Cod, I think the guy's name was Jim Flowers or Jim Flowers you went to school with, I guess, at Penn State.
Yeah, I remember. It was
he commented on something about 70-71, so he wanted to add his 2 cents that there were analysts to 70-71
wasn't an El Nino year, but I remember 70-71, and that was the week that was in New England, where they kept predicting Christmas week storms that turned to rain, and the cold air just dammed up. You had record heat over the southeast. He's probably referring to December 1970. Big ridge over the southeast, but low-level cold air dammed up, and it was great. Every storm just kept coming through. We had a lot of freezing rain in Providence, and it ended, I believe, with the New Year's Eve snowstorm of 1971. So yeah, that I remember 70, 71.
Oh, Jerry Selvin just says he does too. I this weekend we got this like 1040 high over the northeastern United States with an upper level trough and the ridge trying to come at us from the southwest. Pretty
Yeah, I'm a little
interesting.
worried in the mid-Atlantic states. I don't know if it's going to get up into New England. Like I've been saying, I'm looking at this. If I didn't have these models all shoving it to the south, our Spire model, which is we've got a company that we work with that they take European data and create a model, had it coming pretty far north. But those things are like pulling a rabbit out of the hat. But every once in a while, you see them.
Yeah, well, I guess what I'm thinking about is just how the cold is trying to undermine the warmth here, and even on this Thursday, we got this new cold air coming in. Anyhow, freezing rain situation, and so even though the guidance is showing these, building heights, if you have that cold high pressure near the ground, warm air goes over the top.
Yeah, we always used to say that we don't live at 500 millibars.
Well, anyhow, it looks like the questions are slowing down, and we've made it to 7:41, and you can have the last few bites of your. Where are you competing this weekend?
Competing down in DC, and it was very interesting. I was telling the guys before, I totally miscalculated a bunch of things, and I never do that. But the reason I keep competing is it keeps me sharper. I mean, it really does. There's nothing like competition to, and it's not that I don't want to get old. I just want to make the best of what I have with what God gave me. And one of the ways I do that is to do things physically, because if you do something hard that's you're not really supposed to do, it gives you great appreciation for things you've been gifted in. So everything to me, listen, people don't like I say this. A lot of this stuff is spiritual combat, and to me, and I look at the weather now as a way to get closer to God. The weather always was my God up until about 5-6 years ago. Then it hit me that He gave me this love for the weather so I could show some gratitude. And things have changed around, and I sometimes kid around with people I used to work with at AccuWest, saying, "Boy, I'm a lot different now than I was then," because I'd be in a fight every day. I mean, poor Joel.
So you're finding the love.
The thing about Joel was Joel loved to fight. See, this is
Joel was the founder of AccuWeather.
Oh man, where would weather be without what those guys did? Think about it. Everybody just, and of course, a lot of people sort of badmouth the place, and I had my problems with them, but by and large, man, that was just such a weather laboratory. Those guys were unbelievable. But in any case, it's led me to where I am now, and hopefully, I get enough years to complete this. You have to pull me kicking and dragging. Look at DeLeo. I mean, he's better than ever.
Yeah, I'm gonna call him and tell him hello tomorrow. I haven't talked to him.
Well, maybe he was on this. I don't know. I could send him the link.
Anyhow, keep physically active. All right. Well, would you like to sign out with your classic sign out?
I was just hoping you would ask me for that. Listen, no matter what, enjoy the weather. It's the only weather you got.
Thank you, Joe. Great, great.
Thank you for having me. Thank you.
You're welcome.
Bye-bye.
Bye.
I messed the whole damn thing. Didn't have that shit. Oh, Lord, man.